Tesla and Elon Musk have just revealed another major improvement to the Optimus humanoid robot, and this time, the upgrade is making people ask a very interesting question. How close is Optimus actually getting to moving like a real human? This latest update isn't just another minor improvement. Optimus appears to be walking faster, with straighter legs, smoother movements, and a much more natural heel-to-toe walking pattern. For years, people have mocked Tesla's humanoid robot for its slow and awkward movements. Some even joked that Optimus looked like it was walking after an exhausting workout. But Tesla appears to be changing that perception. The newest footage suggests that the company has made significant progress in Optimus's mobility, and if development continues at this pace, the version eventually delivered to customers could look dramatically different from the early prototypes. So what exactly has Tesla changed? Why is straight leg walking such a difficult engineering challenge? And what does this latest upgrade tell us about the future of Optimus? Welcome back to Tesla Car World. Let's get into it. One of the biggest questions people have had about Optimus is simple: why doesn't it walk like a normal person? Instead of standing upright with straight legs, earlier versions of Optimus often walked with noticeably bent knees. To the average viewer, it looked slow, stiff, and unnatural. But there was actually an engineering reason behind it. A robot with bent knees can lower its center of gravity, which can make maintaining balance easier. That becomes especially useful when the robot is dealing with uneven surfaces, sudden movements, or changes in direction. In other words, the awkward walking style wasn't necessarily a sign that Tesla didn't know what it was doing. It was part of the challenge of making a two-legged machine remain stable. But there was another problem. Humans naturally expect a humanoid robot to move like a human. When we see a robot walking with bent knees and stiff movements, it immediately looks artificial. And that's exactly why Tesla has been working so aggressively on Optimus's walking behavior. Earlier versions of Optimus were reported to move at around 1 meter per second, or roughly 2.2 miles per hour. That's not particularly fast compared with some competing humanoid robots. Tesla's longer-term target, however, has been significantly higher. The company has previously discussed a goal of reaching around 2.2 meters per second. And now, the latest demonstration appears to show another noticeable increase in walking speed. While Tesla hasn't provided a precise official speed measurement for the newest footage, the robot appears to be moving at roughly 1.4 meters per second based on visual estimates. That would represent a meaningful improvement. But the speed isn't even the most interesting part. The real breakthrough is the way Optimus is walking. Milan Kovac, who has led Tesla's Optimus development, highlighted several improvements in the latest demonstration. The robot is now walking with straighter knees, a smoother heel-to-toe gait, and more natural arm movement. And there's another fascinating detail. According to Tesla's team, this behavior was trained using imitation learning and reinforcement learning rather than manually programming every individual movement. That is extremely important. Instead of engineers telling the robot exactly how to move every joint for every step, the system can learn movement patterns from examples and improve through training. The latest video shows Optimus walking across a factory environment with a much more relaxed appearance. Compared with older demonstrations, the difference is obvious. The robot no longer looks like it's carefully forcing every step. It looks much closer to simply walking. Making a humanoid robot walk with straight legs isn't easy. When humans walk, our knees and ankles naturally absorb and redirect forces as our feet interact with the ground. Our muscles constantly make tiny corrections. Our nervous system processes information from our eyes, inner ears, joints, and muscles. All of this happens incredibly quickly. Optimus doesn't have a biological nervous system. Instead, Tesla has to reproduce similar behavior using motors, actuators, sensors, control systems, and software. When the robot walks with straighter legs, the system has less room to absorb mistakes. The actuators have to apply exactly the right amount of force at precisely the right time. Too much force and the robot can become unstable. Too little force and it can lose balance. That's why Elon Musk's comment about accurate actuators accelerating automation is particularly important. Optimus doesn't simply need powerful motors. It needs motors that are extremely precise, lightweight, responsive, and efficient. Think of Optimus's actuators as artificial muscles. They determine how much force the robot applies, how quickly it moves, and how smoothly it transitions between movements. But there's a major engineering trade-off. Powerful actuators can provide more force, but if they are too heavy, they make the robot harder to control. Heavy components also increase energy consumption. So Tesla has to find the sweet spot between power, weight, precision, efficiency, and reliability. That explains why improvements in Optimus's walking style are much more significant than they might appear in a short video. A smoother walk means Tesla is making progress across multiple systems simultaneously. Another interesting part of the Optimus story is how the robot handles charging. Tesla doesn't want Optimus to depend on humans for every basic operation. The company's broader vision is full automation. That includes charging. When Optimus's battery becomes low, its system can identify the need to recharge and navigate toward a charging location. The robot can then position itself and connect to a charging system. This is similar in concept to how autonomous vehicles could automatically position themselves at charging stations. The goal is simple: the robot should manage itself. A human shouldn't have to constantly monitor its battery, move it around, or plug it in. One of the more surprising details about Optimus is its battery size. Earlier information about Optimus Gen 2 indicated a battery capacity of around 2.3 kilowatt-hours. That might sound small compared with an electric car. And it is. But Optimus doesn't need an enormous vehicle-sized battery. A humanoid robot has completely different energy requirements. Tesla also has a strong reason to keep the battery compact. Weight. Every additional kilogram affects how efficiently a humanoid robot can walk. A heavier robot requires more energy to move its own body. It can also become slower and more difficult to balance. So instead of simply installing a huge battery, Tesla can focus on making the entire robot more efficient. The philosophy is similar to designing a lightweight electric vehicle: don't just add more energy. Reduce the energy required in the first place. Tesla has indicated that Optimus is intended to operate for extended periods during factory work, with actual runtime depending heavily on what the robot is doing. Carrying heavy objects, walking continuously, and performing demanding physical movements naturally consume more energy. Standing in one place or performing lighter tasks requires considerably less. That means Optimus's real-world operating time will depend on its workload. This is another reason efficiency matters so much. Tesla isn't simply trying to create a robot with the biggest possible battery. It's trying to create a robot that can accomplish as much work as possible with a relatively compact energy system. Walking is only one part of the humanoid robot challenge. The hands may actually be even more important. Optimus has 5-fingered human-like hands designed to manipulate objects with considerable flexibility. That's a major advantage for tasks that require dexterity. A human worker can grab a cup, pick up a small component, hold a tool, open a door, or manipulate an object without needing a completely different machine for every task. A humanoid robot with similar capabilities can potentially work in environments designed for humans. That's one of the biggest reasons Tesla chose a humanoid design. Instead of redesigning the entire world for robots, the robot can adapt to the world that already exists. This is where the Optimus story becomes much more interesting. Elon Musk has repeatedly described Optimus as something far more ambitious than a factory machine. The long-term vision is a general-purpose robot capable of assisting humans in everyday life. Imagine coming home and having a robot that can clean your house. It could potentially prepare food, carry objects, organize items, mow the lawn, or help with repetitive household tasks. Musk has even described a future where Optimus could help teach children, assist with babysitting, and contribute to the production of goods and services. These applications may sound futuristic today, but Tesla's latest demonstrations make some of those possibilities feel considerably less distant. Another potential application is security. A humanoid robot equipped with cameras and sensors could potentially monitor an environment continuously. It could detect unusual activity, recognize objects, and communicate information to a human operator. Because it doesn't need sleep in the same way humans do, it could potentially operate during long periods when human security staff would normally need breaks. Of course, this doesn't mean Optimus is ready to replace professional security personnel today. There are still major challenges involving reliability, perception, safety, and autonomous decision-making. But technically, the concept is becoming increasingly plausible. Healthcare is another area where humanoid robots could eventually become extremely valuable. A capable robot could potentially assist with repetitive physical tasks, transport supplies, help move equipment, or support caregivers. For elderly people living alone, a general-purpose household robot could also provide practical assistance. But this area comes with much higher safety requirements. A robot operating around vulnerable people would need extremely reliable perception, movement control, and decision-making. So while the possibilities are enormous, this is likely to be a much longer-term application. One of Tesla's most interesting advantages could be the way Optimus learns. Traditional industrial automation is usually built around highly specific tasks. Engineers program a machine to perform a defined operation. If the manufacturing process changes, the machine may need to be reprogrammed or physically modified. That can take significant time and money. Optimus is being developed around a different idea. Instead of programming every single movement manually, Tesla wants the robot to learn from examples. This is where Tesla's experience with artificial intelligence and computer vision becomes important. The robot can use cameras and sensors to understand its surroundings and then determine how to interact with the environment. That's similar in principle to the learning-based systems Tesla uses in its vehicles, although humanoid robotics presents a completely different level of physical complexity. Tesla is unlikely to immediately send millions of Optimus robots into people's homes. Factories are a much more controlled environment. Tesla can deploy robots internally, collect data, identify failures, improve the software, and refine the hardware. And that's exactly why factory deployment could be so important. Imagine an Optimus robot performing repetitive tasks on a vehicle production line. It could move components. It could carry materials. It could potentially sort parts. It could perform inspection tasks. It could assist with battery manufacturing. And unlike traditional automation, the same general-purpose robot could potentially learn different tasks without requiring an entirely new machine for every operation. That flexibility could become extremely valuable. Tesla has repeatedly discussed ambitious plans for Optimus production. The company has also been developing dedicated manufacturing capabilities for the robot. The long-term goal is not to build hundreds of robots. It's to build them at enormous scale. And that's where the economics become interesting. If Tesla can eventually manufacture Optimus at a relatively low cost while maintaining reliability, the robot could become one of the company's largest potential businesses. Elon Musk has previously suggested that Optimus could eventually sell in a price range of roughly $20,000 to $30,000, although actual pricing and production economics remain uncertain. At that level, a general-purpose humanoid robot becomes much more accessible than today's highly specialized industrial robots. This is probably the most controversial part of the entire discussion. If humanoid robots become capable enough, they could automate many repetitive physical jobs. That could reduce labor demand in certain industries. But it could also create entirely new industries. Someone will need to design these robots. Someone will need to manufacture them. Someone will need to maintain them. Someone will need to train their AI systems. And someone will need to develop new businesses around them. Just as computers changed the job market rather than simply eliminating every job, humanoid robots could fundamentally change the type of work humans perform. The important question isn't simply whether robots will replace some jobs. The bigger question is, what new opportunities will emerge because robots can perform physical work at scale? Critics often ask a reasonable question: why not simply build a specialized machine for each individual task? And for many applications, specialized machines are still better. But the world isn't designed around robots. It's designed around humans. Doors have handles. Stairs have specific dimensions. Tools are designed for human hands. Factories constantly change. Homes have thousands of different objects. A humanoid robot can potentially operate within these environments without requiring the environment itself to be rebuilt. That's the fundamental argument for humanoid robotics. The robot adapts to the world, not the other way around. Despite all the impressive progress, Optimus still has a long way to go. Walking in a controlled factory environment is one challenge. Living alongside humans is another. A truly useful household robot would need to safely understand thousands of unpredictable situations. It would need to recognize fragile objects. It would need to avoid people and animals. It would need to understand instructions. It would need to recover from mistakes. And most importantly, it would need to operate reliably for thousands of hours. That's why the final stage of development may be much harder than the early demonstrations suggest. But Tesla's rapid progress in hardware, software, AI training, and manufacturing could give Optimus a unique advantage. The most important thing about the latest Optimus update isn't simply that the robot is walking faster. It's that Tesla is gradually removing the things that make the robot look like a machine. Straighter legs, smoother steps, natural arm movement, better balance, more precise actuators, improved hands, faster movement, and increasingly autonomous behavior. Each improvement might seem small on its own, but together, they move Optimus closer to Tesla's ultimate goal: a general-purpose humanoid robot capable of performing useful physical work in the real world. The idea may have sounded like science fiction just a few years ago. Today, we are watching physical prototypes learn how to walk, manipulate objects, navigate factories, recharge themselves, and perform increasingly complex tasks. And if Tesla manages to solve the remaining challenges of reliability, cost, safety, and mass production, Optimus could become far more important than just another Tesla product. It could become the foundation of an entirely new robotics industry. So what do you think? Is Tesla actually getting close to creating a truly useful humanoid robot? Could Optimus eventually become a household assistant? Or are the biggest challenges still ahead? Let us know what you think in the comments. And if you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you don't miss the next major Tesla and Optimus update. Thanks for watching. See you in the next one.